Hello, my name is Emmanuel Garces. I'm going to talk about geographic visualization. So, if you have data that you think you can visualize on a map by using geographic functions, this is the talk for you. I am Emmanuel Garces. I work for Wolfram Research, and I'm going to present you some geographic visualization functions, essentially how to plot data on the maps. The first thing I'm going to show you is, of course, the background for where the data is going to be plotted. We need a background. It's essentially a geographic object. So probably you already have been in Jose or Francisco's talks. They told us about this object or this function that essentially give us a map of could be the region we are in. For instance, this is the map of Champagne, or a country, let's say the US, a city. For instance, this one is the map of Tokyo, or a polygon. I mean, it could be a country, a city, or even a zip code. So essentially, the background with the data is going to be plotted is a geographic object like those presented here. The way we manipulate this graphics object is by using options. So, for instance, this option we have geoscale bar. We are showing here the country of Andorra, and this is showing us the geoscale bar of 5 kilometers, right? So there are different options that we can use for the controlling the output of a very basic map. For instance, we have here the country of Peru, and then we are showing the grid lines. Those are the latitude and longitude lines, by separated by the angular degree of 2. So there are many options for geographics, but those are the main that essentially we are going to use for plotting data. An important one is GeoRange, that essentially gives us the option to show the map of a range of a country, or probably we could we want to have a latitude and longitude ranges, but okay, this example I don't have it here. We can also change the background. We have different types of backgrounds. Of course, we could have non-labels. We could have just the borders of the countries, and also we have satellite views. Francisco showed some more details about this kind of different backgrounds we could have. And another important one is geoprojection. As you can see, there are different geoprojections of the world shown here, but we have several of them. So it's just an example of how different projections we can have in the plot of the map. Okay. We have Geo Visualization primitives, as you probably know if you were in Jose's talk. We can have a geopath, which is essentially a point and then a direction or an angle, and you have a map of how long will you go if you go to the right direction. We have geodiscs, geocircles. This one is a geohemisphere that is showing us if we center the point at Mexico City, how should the map, how should the world look like from that perspective. And this one shows us only the region of the world that is in the night, when I made this image, I was working in the night, so that's why it's night here, right? Yeah. So those are primitives and are the tools we're going to use to plot data into them. Okay. So the first one is GeoListPlot. Basically, it's a function that receives a set of geoposition inputs or entities with some position associated. For instance, here we have the largest city in the USA, and we are showing with points where those cities are located. And in this example, we have a geoposition object that has about 26,000 points of some trees in Champagne. So here's the map of those points, and we're plotting them, right? So we can also plot not only points, we can plot polygons, regions. So in those examples, we are showing the countries of Europe. And here we are showing 3 different sets of countries. So we have different colors separated. So GeoListPlot not only is used for plotting points, but also for showing regions, right? The second function, let's see, some kind of associated to GeoListPlot is GeoHistogram. We also have a set of points, but we are not showing the location of those points. We are showing the histogram of those points. So for the default behavior of this function, we have hexagonal bins. So each bin is showing us an area of Champagne. And if we put the mouse into those bins, we have shown the number of how many trees are over those area, right? But of course, we can change the setting of the bins. We have rectangular bins, triangular bins, or we can change the size of the default hexagonal bins or triangular bins. This one is showing us a bin, but the quantity of each bin is 1,000 acres, right? So that's a GeoHistogram. Sure. Yeah. There's an example here. Okay. Yeah. So there are different ways we can input the data into GeoHistogram. For instance, here we are showing the population of major city. Cities in Europe, and here we are showing the same data, right? So GeoHistogram is not only a histogram of points. You can also associate the region to a quantity or to a number, right? Yeah. So the bins can be also a country or a polygon, zip code, or the polygon of a city, etc. I mean, it's not limited to just hexagons or rectangles or triangles, like in this case. Those are the same data, but the bins are different. Okay, that's GeoHistogram. Now we are going to GeoRegion value plot. The main idea of this visualization function is associate one entity with a position and then one value. So we are showing here 3 countries associated to the 3 different values, and each one is colored with a different color, right? In this example, we are showing the per capita income of different counties in those states in the USA. So that's what is useful GeoRegion value plot, right? Okay. There are some other ways to visualize data, like in G-region value plot. I mean, having entities with some value associated, but instead of colors, we might want to have visualization like in bubble chart, right? So we have Geo bubble chart, Geo 11.1. Those are entities and values associated that can be plain values or quantity values. So here we have the population of countries in South America. Interesting example that I made here is the magnitude of last earthquakes in the last 2 years in this zone of Mexico, right? So we are using here callouts. As you can see, the data is wrapped by some callouts. Here we have this callout that is a new functionality for charting functions. So I'm showing here those recent earthquakes that happened in Mexico. By the way, this was really was really strong. This one. Okay. Following with examples, we can also have different types of elements for your bubble chart. Not only bubbles, but we can have, for instance, pie charts. This example shows the farmland area of each state in the USA. So as you can see, the yellow area is the land that is not a farm. So you can see Alaska, of course, has very, very, very few farmland area, right? And we have Nebraska here that I think is the country. I mean, is the state of the country that has the more land area. So this is showing how can we convert bubbles into different objects, and the size of the object is going to be proportional to the value we have associated to the bubble size, right?
What is it in this case?
The farmland area.
Well, I mean, the bubble size is area of the city.
Right, right. Yeah, because the data, if I didn't show pie charts, I will show bubbles, and the value associated to each entity is the area of each state. So that's why Alaska looks bigger than the others, and we have Texas here bigger than the others, and so on. So this new function supports many kinds of inputs. If you have this presentation on your laptops, you can prove that those 5 different inputs are representing the same data, so the output is going to be the same, right? Okay. Now, as you probably have seen in other visualization functions, we can use show to combine different outputs. So in this case, I'm showing how we can combine an output from Geo Histogram. Here we are showing the number of students of the 4th school district of Champaign. So each bean is showing how many students are there, and the second geographics output is the geomarker of the position of each one of the schools, and we might want to show how do they look like together. So we are showing we are using show to mix the histogram and the markers, and we can do this with more functions. I mean, we can combine 2 or 3 or more functions in the same map. Finally, I'm going to show, let's say, an experimental function for 11.2 or something. That's dynamic geographics. And this is basically a function that allows us to interact with the map. And the output is a map that can be pamped and zoomed. So those are the buildings of New York and the position of those buildings. And we can interact with this by clicking here as a zoom. Okay. Well, let me just try it again. I'm not sure how many times it's going to take, because I tested this one before the talk, but anyway. Meanwhile, do you have any questions? Yeah.
In Geo Histogram, is there a way to get an ISO of the particular quantity being measured, similar to an altitude sort of topographic map, but for the quantity? In other words, so a line of constant number of trees, an area that contains that number of trees?
Do you mean the reverse thing?
Sorry?
So you
It's kind of, yeah, I guess it's
Yeah.
kind of opposite, but basically, you have these quantities at locations.
Mhm.
Can you take that and say, create, instead of various colors, lines that separate those colors?
that could be a different plot. Yeah. Yeah. Right. Yeah. That's going to be a different project. Yeah. We don't have still that function, but
Closer to smooth density histogram, because you want to take the points and you want to take that to a continuous distribution, whereas geohistogram that we have right now is discrete measurements within an area. So that, I don't know if you're showing that, but that's coming up next.
yeah.
Oh, I don't think he is showing it.
No, I wanted to show it, but
Thank you.
yeah, that's the next function in the pipeline. So okay. So we have a cloud of buildings here, but I want to go into those buildings. I just click here, and then I can get, of course, a better tiling of the map of Manhattan, and so on. And I think that's it. That's what we have. Thank you.